Okay, our next section is about absolute value inequalities. We just talked about absolute value equations, and we had to set up two equations, one set equal to a positive number, one set equal to a negative, and then we solve those. Absolute value inequality is going to be very similar. We're just going to need to be careful because now we're talking about inequalities, so we could be talking about, we're going to have to answer in interval notation. The nice thing about inequalities is you've got really two rules. If you have an absolute value is less than a number, then we're going to be able to make it into a compound inequality that's pretty easy to solve. If you have an absolute value set greater than a number, then we're going to have to make two absolute value equations out of it. And really, when you do a compound one, you're making two equations. It's just that we usually are squishing the x in between two endpoints and solving it all at the same time. So just keep in mind those rules. I would put them on a note card. These are the rules that I'm talking about right here that are in the middle. I would, either put an example on a note card or put those rules on a note card just to help you remember. Again, we're going to have to make sure our absolute value is isolated. And we also are going to need to remember that if we have a negative number on the right side, then all absolute values are greater than a negative number, but you don't have any absolute values that are less than a negative number. But I'm not sure we're really going to run into that too often. All right, so in this first one, I've got absolute value of x plus 3 is less than or equal to 5. On a less than, I can take my x plus 3 and I can put it in between my two endpoints, 5 and negative 5. I put the negative 5 on the left because remember we're using our common sense superpower. Negative 5 is to the left of positive 5 on a number line. And then we're just going to subtract 3 from all sides. So I'm going to get negative 8 is less than x is less than or equal to 2. The great and wonderful thing about compound inequalities is that they're easy to graph and they're easy to get interval notation from. Because negative 8 sits to the left of a positive 2. That makes sense. I have a less than or greater than or equal to in both of these, so I'm going to get a bracket. And then I would connect the two to show my graph. So my interval notation is coming from my graph. I have a bracket at negative 8, comma 2, bracket closed. Not too bad. Less than ones are a little bit easier. When we get to greater than, we're going to have to think about it a little bit more. All right, here's another one. This one is not set equal, or this one is not isolated from absolute value, so subtract your 3 from both sides. So the absolute value of x minus 5 is less than or equal to 5. 8 minus 3 is 5. So again, I have 5 for endpoints. Again, on this one, I'm going to come over here and I'm going to have x minus 5. I'm going to put it in between positive 5 and negative 5. And then to solve this one, we need to add 5 to all the spots. So negative 5 plus 5 is going to give me a 0. I've got an x in the middle. 5 plus 5 is 10. So my graph would look like 0 and 10. I've got a bracket on each one because I had an equal to, and I would connect. Then I would write my interval notation. To me, it is so much easier. Even if you're not asked to make the graph on these, you're asked to write your answer in interval notation. It's so much easier to get your interval notation if you draw the graph. Okay, the next one already has that absolute value isolated. So I just need to come over here and put 5x plus 7 in the middle of 2 and negative 2. In all these examples, we've had less than or equal to, and so I'm having brackets on all my graphs because of that. Okay, I'm going to subtract 7 everywhere for my first step. I'm going to have negative 9 is less than or equal to 5x, less than or equal to negative 5. And then we're going to divide everything by 5. So I'm going to have negative 9 less than or equal to x, negative 9 fifths, less than or equal to x, less than or equal to negative 1. So I'm just sketching a graph. Again, it's not really asking me to graph it. I'm just doing it because it helps me get my interval notation. So my interval notation would be negative 9/5, comma negative 1, with a bracket around each one. Okay, let's look at the next one. It is not isolated. Got to do a little bit more to this one. So the first thing you want to do is move the negative 3 over. So I'm going to add 3. So 7, absolute value of x plus 1 is less than or equal to 14. Now I want to move the 7 that's multiplied in front because I need this absolute value to be by itself. So x plus 1 in absolute value is less than or equal to 2. Now I can take that absolute value and put it between my endpoints 2 and negative 2 and subtract 1 from everywhere. So negative 3 is less than or equal to x is less than or equal to 1. My number line, I'd have a negative 3, I'd have a 1. Brackets on all these. All of these have had brackets. Now on homework you're liable to not have all brackets. Negative 3 to 1 for my interval notation. All right, now this page we are going to have greater than. So remember, if we have greater than, that means when you take the absolute value out, you're going to have x is greater than a or x is less than negative a. That is how we're going to set these up. First, you need to make sure your absolute value is isolated. So in this first one, it is isolated. So I'm going to have x minus 2, take that out of absolute value, and then it's going to be greater than or equal to 7. So really, what I'm doing first for my first equation is I'm just taking off the absolute value part and writing it just like it is. My second equation is going to be x minus 2 then is less than or equal to a negative 7. And then we're going to work each one out from there. So I'm going to add 2 to both sides. So x is greater than or equal to 9. That is the first part of my answer. Or we're going to add 2 to both sides on this one. X is less than or equal to negative 5. So let's come over here and draw my number line. Not very straight, but you get the idea. Greater than or equal to 9. So there's 9. Greater than or equal to would be a bracket, arrow going to the right. Second part says less than or equal to negative 5. Let's just say negative 5 is down there. Less than or equal to would be a bracket, arrow going to the left. So now I've got it right interval notation. And remember, these were or statements, so they are union statements. So I need to put these two graphs together, and then I'm going to connect them with a union symbol. So I'm coming from negative infinity to negative 5 with a bracket. Parentheses are always around infinities, don't forget that. And then a bracket 9 to infinity. And so that's how I show interval notation for this answer. Just a tad bit different than what we were doing. All right, let's look at the next one we have on here. 2x minus 1 greater than or equal to 5. I'm going to do the same thing. We're going to have 2x minus 1 greater than or equal to 5, or 2x minus 1 less than or equal to negative 5. Let's solve each one. So I'm going to add 1 to both sides. So 2x equals, greater than or equal to 6. Divide by 2. So x is greater than or equal to 3. Or, I always like to write that little or in there so don't forget, add 1 to both sides. So 2x is less than or equal to negative 4. Divide by 2. X is less than or equal to negative 2. So let's come over here and sketch me a number line. We'll have a 3 on here, and it's greater than or equal to, so arrow going to the right. I'm going to have a negative 2 on my graph, less than or equal to negative 2. And so to write interval notation, negative infinity to negative 2, 3 to infinity, union. You see how easy it is whenever you are looking at your graph to then come down here and write that interval notation, because you're just writing exactly what you're seeing on the graph, just using interval notation. All right, so let's think about number 6. 7x plus 2 in absolute value greater than or equal to 0. Well, let's think about this. Aren't all absolute values either greater than or equal to 0? Because didn't I tell you that all absolute values had to be positive? So we're going to use our common sense superpower on this one. If I've got an absolute value greater than or equal to 0, it doesn't matter what I'm putting in there. The answer would be all real numbers, because any number you put in there, once you take the absolute value of it, it's going to be bigger than 0. It doesn't matter what the number is as long as it's bigger than 0. That was kind of a trick one. All right, let's look at the bottom. 3x minus 8 greater than 9. So 3x minus 8 greater than 9, or 3x minus 8 less than negative 9. Solve each one of them. So 3x is greater than 17. Divide by 3. X is greater than 17 thirds. On the other equation, I'm going to add 8. So 3x is less than negative 1. Divide by 3. So x is less than negative 1/3. I'm going to put my or in here. So keep in mind, I'm just drawing sketches of these graphs. So I'm just guesstimating and making sure I know in what area. 17 thirds is positive, so I'm putting it positive. Aha! This time I didn't have an equal to, so I'm going to have a parentheses this time. Greater than goes to the right. Negative 1/3 would be somewhere down here to the left because it's negative. Less than gets a parentheses, arrow going to the left because it was less than. So then the interval notation, I'm coming from negative infinity to negative 1/3, parentheses around both of them this time. I'm going from 17 thirds to infinity, and then I'm going to put them together with the union symbol. That's just a blank slide, so that's the end of absolute value inequalities. Be sure that you contact me if you have any questions whatsoever. You have my email address, you have my phone number. I'm expecting questions if you have them. Thanks.